We are now going to begin lesson 3 in chapter 10. This is video 1, and we will be looking at geometric sequences. Again, notice we have a sequence of numbers, but since we're looking at geometric, remember, oftentimes when we look at geometric, now we're looking at multiplying instead of adding. So let's see, here we are timesing by 2, timesing by 2, timesing by 2, timesing by 2. So geometric sequences, we have repeated multiplication. That's done by using exponents. So if we were to look at this sequence and try and write a formula for it, we would say to find the nth term, we would take the first term and multiply by the number that's being repeatedly multiplied. In this case, the number is 2. We call that the common ratio. So 2 is the common ratio, which we call R. So multiplied by R, and again notice that just like when we were adding, it's always one less. So at the second term, I have one multiplication. On the third term, I have 2 multiplications. On the fourth term, I have 1, 2, 3. On the fifth term, I have 1, 2, 3, 4 multiplications. So this R is going to be taken to the n minus 1 power. And we could do this, maybe we might want to find the 7th term of the sequence. So a sub 7 would be the first term times the common ratio to the 7 minus 1 power. In this case, that's equal to 2 to the 6th power. And 2 to the 6th power is 64. So the 6th term, or the 7th term, is 64. Let's look at another geometric sequence, just so we can see how they look. Here's one that's not so obvious. 1/3, 3/5, 3/15, 9/75, 27 over 375. Well, we notice on top we have a common ratio of 3. In the denominator, I have a common ratio of 5. So here I can see that the common ratio is 3/5. The general formula for this would be a sub n is equal to a sub 1, which is 1/3, times the common ratio, 3/5, to the n minus 1 power. If I wanted to write this as a recursion formula, where I go from one term to the next, to get a sub n, I have to know what the term before was. And so a sub n, in this case, would equal to the previous term, a sub n minus 1, times 3/5. And this would be a recursion formula. This is an index formula. We then can use this to solve various problems. Let's write our formula up here that we'll be using. A sub n equals a sub 1 times the common ratio to the n minus 1 power. And let's find the 8th term of 1/4, 1, 4, and 16. So the first thing I need to know is, what is the first term? Well, I see the first term is 1/4. We're looking for the 8th term, so that means n equals 8. I don't know the common ratio, but I can figure it out because I just take a term and divide by the one in front. 16 divided by 4 is 4. 4 divided by 1 is 4. So the common ratio is 4. Now I'm ready to find the 8th term. A sub 8 is equal to 1/4 times 4 to the 8 minus 1 power. This is 1/4 times 4 to the 7th power, which is 1/4 of 16,384. And that's equal to 4,096. So that's how we use the formula to find a term using the geometric index formula. Let's do another one to finish off. If a to the 5th is equal to 48 and the common ratio is equal to 2, find a sub 1. Well, a sub 1 is equal to, a sub n is equal to a sub 1 r to the n minus 1 power. Okay, in this case we have a sub 5, which is 48. The first term we're trying to find, we'll just call it a. The common ratio is 2, and we see that n is 5. So this means that 48 equals a times 2 to the 4th power. So 48 equals a times 16. And dividing by 16, 3 equals a sub 1. And so we were able to find the first power. This should give you an opportunity to complete a major part of your assignment.